Vectors. Today we're doing vectors.
Please. No, like, okay, straight from the start now, and I would have a phone for the class, and I will go. So, by chance,
Sit down and come to class later. Alright, so what's here? Right, so we need to remember a few things about vectors, right? Remember OP, we call OP a position vector. So for example, if I give you O here and a point P, O to P is what we call the position vector, right? Everything is advanced, right? Let's go over this first. Right, remember that we could write a vector. We could write a vector like this, xy point, or you can write xi plus yg. Right? If instead of going O to P, we go P to O, what does happen? What you guys do? Yeah. Yeah, you just put a minus sign, right? Just put a minus sign. Okay? So you put minus x minus y. Right. If two vectors are equal, then what we can say? The coefficients of I equal to the coefficients of I equal to the coefficient of G. Right? So A equal to C, B equal to C, right? Next, how do we add and subtract vectors? Add the x, add the y. That's okay? What would happen if adding Z now? What you would do? Add the x, add the y, add the z. Okay, same thing. How do you multiply by a scalar? Multiply both values, right? So you multiply k by the x value, k by the y value. And next, how do you multiply two vectors? You multiply the x, you multiply the y, add them. What is called again? What is called the multiplication of two vectors? Dot product or the scalar product. Nice. Dot product or the scalar product. Right? Next, how do you find the magnitude of two vectors? Square root of x squared plus y squared. What's a unit vector again, Faith? Since you don't have time to watch the one board then. Tough enough. What is called a unit vector again? Yeah? Or yeah, you just read it away. Right. Right, so you divide the vector by its magnitude. Okay, so the magnitude is 1. Next, how do you find displacement vectors, right? Let's quick glance here. How do you find AC? What you do again? Find the alternate route from A to C along the triangle. So you go A to B plus B to C. What would happen if it's not a triangle? Same thing, right? Even if it's a quadrilateral. If it's a quadrilateral, same thing. Find the alternate part from the first letter to the last. Right? And last thing that we need to remember is how to find the angle between two vectors. Right? Dot product over the product of their magnitude. That's okay? Darian, if the vectors parallel, what we know? If the vectors, they are multiples of each other, right? And if the vectors perpendicular. Anybody, Marquis?
Oh, yeah, when you multiply them or something, when you find the doctor,
It'll be 0, right? Dot product is 0. Alright? If you want the screenshot, take a screenshot. It's fast. Anybody can screenshot online? Screenshot and share the group now. Those who have the AdMath summary from last year, I said, right? Online, to just screenshot that now. and head up three dimensions. No, don't copy that down. Just copy down with three. No, don't copy it down. Copy down with three dimensions. I'm going to right now.
But yeah, all right, good way to think of it, don't you? Better than that.
Anybody do it online? Somebody do it? Come, somebody. So you're gonna do it online?
So what that guy said.
Happy.
What that guy.
Someone. Huh?
Nobody got it.
Alright, let's go. So three-dimensional sectors, right? So what you see? I can't really draw it, so right? So if I give you three dimensions, right? We're focusing on the X, Y, and Z plane. Right? So imagine a point here. That point, if we draw it relative to the origin, that point can be written like this. OP, right? Remember to put the line on top. OP can be written like this. OP could be written like this. X, Y, Z. Oh no, there's no right? X, Y, and Z, right? So this point here has an X value, a Y value, and a Z value. That's okay? And we could write the vector like this. Xi plus Yj plus Z K. Anybody remember when I, J, and K?
Yeah.
Anybody remember what I, J, and K? I, J, and K they are unit vectors. I, J, and K are unit vectors in the direction X, Y, and Z respectively, right? So basically, I, J, and K giving it direction. So J tells you that this value is in the Y direction. K tells you that this value is in the Z direction. Okay? So these are unit vectors that give it the direction. All right? So nice. So those are some of the things that we need to know. We could obviously find the magnitude. We could find the magnitude of a vector. How would the formula be, Faith? What would the formula for the magnitude here be? Very good. It will be x squared plus y squared plus zero. Oh, no, here. I'm going to see. Right? X squared plus y squared plus z squared. That's okay? That's the way you find a magnitude. What's a unit vector again? A unit vector has a magnitude of 1. So how to find the unit vector? All we have to do is to write, like for example, p over its magnitude. Okay? So please remember that the magnitude of this is magnitude is 1. Right? So we need to remember those little things about a vector as it pointed out before, Marquis. How you find P O again? Yeah. If OP is excellent, very good. Sorry? Right? So OP will be minus X, Y. I didn't know you said that. You know what? Alright, so let's say we have those three vectors, right? And we want to be able to add and minus and subtract things. Marquis.
Sorry.
Yeah.
Yeah, I know, it's kind of crazy.
Alright, so here's how it try to summarize based on your knowledge from two-dimensional. See if you can add, minus, multiply by a scalar and multiply. See if you can try A, B, C, D there. Everything you did in 2 dimension, do it right here. If you remember, it's stuff from 2 dimension, if you can go down this here. Right, every time I listen back to that video, I will hear you.
Nasir, I listened to your old video till I hear this Iran. Iran. Hi, Basad. Yeah. With that one. Yeah.
Ready? Right, so in order to work these out, right? Which form we using, the IJK form or the matrix form? Right, so you're writing 3 minus 2, 5, right? Or you call it back. This is 5, 4, 2. What's this one? What's this one here? 2, 0 minus 3, because there is no, right? There's no y component, right? Right? Hurry up, work out these here fast. Not chat, not going to chat. All right, time up. Let's see what you got. Right, so A plus B, that'll be 3 minus 2, 5 plus 5, 4, 2, 8, 2, 7. Everybody get up? Yeah. Nobody get up? Right here, 3 minus 2, that's 1. Minus 2 minus 0 is minus 2. 5 minus 3 is 8, right? So you're minusing the x, the y's, and the z. Okay? So when you're doing questions like this, it's good to put it in this form, right? Right? What is 3a? Right? 3 by 3, that's 9. 3 by minus 2. 3 by 5 is 50. That's okay? Right? I just want to go over this one here for Jilon. Huh? Right. So here's multiply again, Keshav. Here's multiply two vectors. X by x, y by y, z by z, and then what? Add it up, right? So 3 by 5, that's 15. Minus 2 by 4, that's minus 8. 5 by 2, 10. Right? So that's what? 17. Everybody get up? Yeah. Right, so I just did an example because I just want to show you how you handle 3, right? Same thing I did in 2, you do it in 3. Kalina, which one? You good? Right, suppose I just wanted to squeeze in one thing here, Shanna. Suppose I wanted to find the unit vector. I wanted to get the unit vector of B. I want to get a unit vector P. How you do that again? How you get a unit vector P? How you get a unit vector P? By the way, how you write unit vector again? What's a little symbol? Like a little hat on top, right? A little hat, right? Yeah, so you write the vector P, right? P was 5i plus 4j plus 2k all over its magnitude. How much is that? That's 45. 45. Right? That's 45. Any questions online? Chelsea, are you okay? Right. So what is here? Jacob. Please find AB. How do you find AB? Find the alternate root. find the alternate route from A to B, right? What would that be? AB is what? AB will be A to O plus O to B. A to O plus O to B. What is A to O? Minus of this, right? Yeah, Chuck? A to O? A to O is what? How you find A to O? No, we found AB already, yeah. AO plus OB. But the question I'm asking is how to find AO. We have OA. Plug in what? But there's OA and then AO. Flip it. Flip it up, change the sign. Oh, I flip it. All right, so -2, -2, 3, 4. And OB is 1, 1, 2. Right, so -2 plus 1, 3 plus 1, -4 plus 2. All right, that's the way you find AP. Right, see if you remember how to do this. See if we can find that somewhere. Same diagram. C is in middle. C is the middle. Find OC. I know. Check for that. Huh? Nothing. Feedback. Oh yeah, find OC, right? Find OC. C is the midpoint push-ups. It's the midpoint of AB. Sorry about that. C is the midpoint of AB. Did you even realize?
Yes.
Right, so you should have the different diagram. C is in the middle. And you draw a line O to C. Right, so O to C is what? O to B, B to C, or O to A to C. Which one nicer to use?
A.
Why?
Because A, B, A to B. It's C is the image between A to B. So
Because you're going with the arrows, right? Whenever you go with the arrows, it's easier, right? You have to put a minus sign.
Yeah.
Right? So O to C is O to A to C. Right, O to A was 2 minus 3, 4. And A to C was half of this. Right, half of this, because this is AB, right? Half of that. So it's half of minus 1, 4, minus 2. Okay, I have that up now. Right, I am getting 1.5
1.51
minus 1 and
three.
I will minus 3, right? That's okay. So in order for right? So please remember that whenever you're doing this placement vectors, get a nice diagram and work it out, right? But in pure maths, they don't really give you like the ratio 3 to 1 and things. Right? There's actually like these basic things there. AB. Right? AB is A to O. Everybody okay with us? Everybody okay with us, right? Yeah? Jesse? All right, nice. Last thing that we have to do before we complicate it a little bit is we're going to find the angle between two vectors. All right? What's the formula again, Darian? What's the formula for the angle between two vectors? Right? Angle between two vectors, right? Yeah. What's the answer?
Try what's it? Cos theta is equal to the dot product over the magnitude.
Over the product of their magnitude, right?
Yeah.
Right? So this is how you find the angle between two vectors, right? Right, Jacob? And if theta is 0, what is called that? If the angle here is 0, two vectors are what? Two vectors are? Division. The vectors are what? Right? Vectors are parallel. Right? Which implies that right? So I want you to recognize two things, right? If the vectors are parallel, the vectors are multiples of each other, or the dot product is equal to the product of their magnitude. Okay, you hardly ever use this though. K-sharp, you hardly ever use this, right? It's more use this underneath. What would happen if theta is 90 degrees? Vectors are what? Vectors are?
Perpendicular shift.
Vectors are perpendicular and the dot product is 0. All right. So we gotta remember these little things, right? Copy it down. Let's try a couple of past papers and then change up this whole thing. Press.
That's French. That's nice.
Did you win it?
Yeah.
Of course.
No, Ramon's up.
Yeah.
What do you got? Alright, let's go again. Past paper. The one I'm giving you here is 2000 and, alright, let's go. Hurry up. Try that in. And that's 2016. Try that, please. Boy, so,
So we have watched on. What year this is?
It's 2016.
What question?
So, yeah, so I thought about that.
No, back up, Mr. 20 details. That's I think now number 4 part B in 2016.
Yeah. Right.
Might be 2 feet.
Plus. The root of X squared. You see, you X squared plus, you understand? I know it's exciting, it's not saying you can't do that, something you never. Oh, it's there.
Question answer be. What? Must be done.
Yeah.
Have it finished?
Yeah.
Sound.
Or like just come up when you get to the angle, right? So I'll do questions until you finish, right?
The 26 number one.
I'm a 4-5.
Send it to you, thing on the side, and you watch. That's not. You do, them side, man.
Ready? I can start looking it out.
No.
Come here. Make it clear. Finish.
Yes, sir. No. The full way, full. So, that would be real, yeah. I get wrong. The error. I have.
Anybody get that? 30. You'll get those two values. And then theta will be. Oh wait, let's try and do that V one time.
Oh, somebody put it. Hello, no. 63.9. It does,
Anybody get 9? Please do that V.
yeah.
Yeah? So theta will be cos inverse 9 over 2 root 14 root 30.
Then 2 root 105.
How much is that?
2 root 105.
No, I just got the angle.
Or 63.95.
Anybody else get that?
Yeah, yes.
Yeah?
Again.
Anybody get 64? Around that, right? 64 degrees?
Again. Hey, what? Since I shut everything, I'm not happy to go out. Yeah. So,
Oh, yeah. That's true. They absolutely cos theta. Cos theta is how much? Sorry. Yeah, they are cos theta. Thank you. How much is that? I got it defined. You sure? So it's 9 over this whole thing?
Yeah.
Alright, let's go again. Next one.
105.
2 is 1
9 over 105.
Oh, okay. That was not, all right.
It's 105 and 7. No, that's not it.
Everybody right there? You okay with this one? Jack? Try this one here, 2014.
Yeah, that's it.
I have 2014.
Yes, sir, you can come on. Now, when you start something, you can put that. It's actually important.
I have 2014.
Yes, sir. Can you sit on it? I don't give you good. You want to write like boys.
A little bit longer, right? Find PQ, QR, RC.
What year is this? 2014.
Number 4 part, part C. Yeah, that's lambda. Minus 1 lambda 5, right? That's Q.
Please.
Now tell it. Oh wait, sorry, that's the fire. I now see it. Sorry, I messed up. Try this now. Take it down. Time away back. I got I PQ. Oh, I forget this. No, stop. Hey, come back.
Oh, yes, sir. So many years.
Good boy.
No, press before. Exactly.
Wait, now come on. 1.
Say a lie.
Now come on. 1. Right, we'll go down there. Yeah, should we again? PQ. What else? You gotta do all that. PQ is what? Pizza? Pizza? Pizza Q? How pizza Q is pizza Q? Pizza O to Q, right? And you have everything you need right there. Everything you need right there, right? You have OP. You have OP 3 minus 2 1. You have OQ minus 1 lambda 5. And you have OR.
Yeah,
Yeah, they give it PQ and R, they give it
Oh,
point. So yeah, they get PQ.
yeah.
Oh yeah, find all of them. And then find lambda, it is perpendicular. Shall we do the next?
No.
Right, take your time, find PQQR, right? In part two, draw the diagram. And I tell you where your right angle is, right? And again, PQ. Black hole. Yeah.
Says no man anything car, right? Should they say this thing? Are right?
Street of, right? So what is it? PQ as you are.
But I wrote, what?
Can't be done because. Because you can read it also clockwise.
It is shipping. It's shipping.
You can leave it up and clockwise.
So you know any that shut up that nobody knows.
Let's focus out. Last one are we doing it, then we start in back. Okay, that's doing it and then we start back. I don't know why I feel so All right, let's take a look at this here. Right? Remember for part 2, draw a diagram so you know where the right angle is, right? Right, I'll come and do it in board just now. Yeah, and so let's what else 2 minutes break?
Yeah.
No?
Yeah.
All good? We're talking that's mine.
I just not.
All right,
Yes, I did, but.
let's give it a little start there. We need PQ,
Oh, is that?
right? Right, let's go. Right, so the first thing we need is PQ. PQ is PO plus OQ. Right, so that'll be -3, +2, -1. OQ is here, -1 lambda 5. Add them up, you'll get -4, 2 plus lambda 4. That's okay? That is your PQ. QR will be QO plus OR. QO is 1 minus lambda minus 5. OR is 2, 1 minus 4. So this will be 3, 1 minus lambda minus 9. Huh? No, I remember it's PQ will be PO plus OQ. So I'll change the signs, right? Nine doing that. And once again, RP. What's the last one? RP? RP is RO plus OP. RO, that will be -2 minus 1, 4. OP will be 3 minus 2, 1. At the top, you'll get 1 minus 3, 5. Everybody get it? Yeah? What is set after in part 2? What was the hypotenuse? Right? They said that PQ was the hypotenuse. Right? So it means that if here's P, here's Q, here's R. Right? Remember, markers you can label clockwise or anti-clockwise. Okay? So therefore, here is the 90. So because here is the 90, we could say that RP, we could say that RP multiplied by RQ, right? What is equal to? Esther, what is equal to? RP by RQ. Because it's perpendicular. Equal to? 0. Right? Are you done? That's okay? So the diagram here was important to know. Well, you get to lambda? What you get for lambda? That's how we did on stage up there. And what you get for lambda? Take up where you get for lambda. Just multiply it out. Hurry up. Right, finish up the rest there. Amber, you okay? Bradley, you're doing your work, right?
Yes, sir.
Find lambda. Where you get the lambda, Bradley?
Negative, QR. So it is negative three. Minus one plus nine. Yeah.
Fifteen, all right, nice. Okay, Sharp, you got 15, so I finish it up. RP is, Marquis to finish this?
Yeah.
Oh, so you can talk, all right.
Minus 15.
Right, RQ was change the signs, right? -3 lambda -1 9. And that was equal to 0. So it's -3 plus -3 by lambda -1. 5 plus 9, right, by 9 is 0. So -3 lambda plus 3 plus 45 is 0. Now cancel. All again minus. All again minus or plus 15. Plus 15, right? I got 50. I got plus.
I have plus.
What you got? Victoria? Enters? No, remember is RP by RQ. This is QR. So I change the sign for. So it will be -3 lambda -1 9. I change the signs. It will be lambda -1. Not too sure about. I wasn't bothered. All right, so guys, I'll give you a few minutes there and then we start back to the equation of the line. Right online, I'm giving you a 6-minute break. Then we start back the equation of a line. Right online, take a 6 minutes, right? Then we start back the equation of a line.
Man, all kind of thing.
So you want to talk about that, right?
Yeah, you know, that's why we didn't talk about that.
40-year-old man, that way.
Right. You're going out all this.
I am on the
You're going out all this.
I am on
Is that not?
Yeah, I know.
Right.
I do.
Now what?
You're going to. Oh,
And it's like this. But it basically. So it's like basically.
so we've not it.
No, it basically. You know, basically.
Vector equation of a line. Right, so for those that didn't do vectors, this is something new here that we're gonna do, right? Vector equation of a line. Right, so. Imagine this, right? So far, what we have been doing, right? Darian, so far we have been, for 3D diagram, we have been finding the vector equation or the vector of points, right? We have been doing a point all the time. Now, we're going to combine these points and we're going to now get something called the vector equation of a line. Okay? All the time we've been finding the vectors of a point. Now we're finding the vector equation of a line. And after that, we're going to combine these lines. And these lines is what we call a plane. That's okay, you all know what plane is?
Yeah. Yeah.
Right? So imagine this first, right? We have 1 point. Right? That was the xy plus yj plus dk, right? Then if you combine, we end up with a line. That's okay. So this here, what you see in here is a line. Here. If I combine all these lines now, you get a plane. This is a plane, right? A combination of lines. We have to get the equation for a line and then combine it into a plane. That's okay. And that's it for vector. Vector equation of a line and then a plane, and that's it. Right. How we get in vector equation of a line? Well, you all remember the equation of a line? Okay.
Yeah,
No, it's just not too much.
sorry.
I know, I was about to say, say quiet. Right, so you all remember the equation of a line? What was the equation of a line, please? Y is equal to, right, so here's what you need. Right, you need something that will give you direction. And you need a point on the line. All right, so in order for us to find the vector equation of a line, we need two things. We need something that will give us direction, and we need a point on that line. All right, so watch this here. Maki, so go article the rest now. Right. So I would like to get the vector equation of that line. All right. Here's what here's what they're going to give me. They're going to give me a vector parallel to it. Right? They're going to give me a vector parallel to it. This vector will give me direction. And then we're going to get a point on it. Let's call it point E. All right. We're going to use these two things to find the vector equation of a plane. All right. So watch this here. We're going to find the position vector of E. Right? That's OE. And we're going to choose one random point that's always moving, right? Let's call that point R. And I'm going to find OR. We know OR, right? Let's call OA small a. Let's call OR small r. Everybody okay with this? Everybody okay with that so far? Right. How are we going to use this now to find this equation? Really easy. Watch this here. Anybody can tell me what's AR? What is AR? Based on our diagram, AR is E to O, O to. So it's E to O plus O to R. E to O is what? E to O is this way. So that's minus E. And O to R is R. Everybody okay with that? Right. But what you can say about AR and P? What you can say about AR and P? They are parallel. Parallel vectors are? Parallel vectors are multiples of each other, right? Scalar multiples. So it's a multiple of it. So that is lambda P. Can't believe that man said that. Right? So it's lambda P. So if I wanted to make R the subject, remember R could be any point on this, right? R will be equal to A plus lambda P. That's it. This is your equation of a. This is your vector equation of a line, right? Where A is a point on the line, A is a point on the line, and B is the direction vector. The direction vector parallel to the line, right? I believe that down. Remind number one student. All right.
Just because they're jealous, don't mean guys.
What? Let me tell us all.
What? What?
Right. So in short, all we need, Jadon, is a point on the line and a vector parallel. That's okay? Plug them in there, we got to. All right. That's called the vector equation of the line.
So,
I'm going to show you how to get the parametric and how to get the yeah.
what's that after B? In front of vector, but after B. Swipe, that.
This
Like the arrow.
is a arrow.
Oh, I think it's good.
Huh?
I think it's good.
Because it's parallel and perpendicular. It's parallel perpendicular. It's a parallel perpendicular. Right?
Say, it's two classes, the last one. Say, I see that. It's two classes, the last one.
I teach class online.
No.
Now, Alia? Monday.
Depends on what to tell you what to do. Yes, 20 minutes. Yeah, but you can pass.
Oh gosh, you gotta get stoned. Right? So let's do a couple examples.
Yes, I've been done. That's crazy.
Alright, let's go. Example one. Ready? Example one. A line passes through. Yeah, because I'll just walk in. A line passes through the point. A line passes through the point 1 minus 3, 4. A line passes through the point 1 minus 3, 4 and is parallel to 4i minus 3j plus k. Right? But let's find the vector equation of the line. Vector equation of the line. Right? What we need again, Kiran, to find the vector equation of a line? What we need again? We need a point on the line and we need we need what? Parallel to vector, right? So we're using r is equal to a plus lambda p. So the vector r is equal to a. So all we have to do is write this point as a vector 1 minus 3, 4 added to lambda p. P is the parallel vector, which is 4 minus 3, 1. What we did, Darian, but while I wasn't paying attention, we plug in A, clean up, and we plug in the direction vector here. 4 minus 3, 1. Okay? Yeah. Got it. parallel to 4i minus 3j plus k. 4i minus 3j plus k. Online, any questions on this?
No, I didn't make them here.
As per my mommy downstairs, he didn't tell her it was You can leave it up. Right, watch this here, everybody watch here. I want to show you how to find another form, right? So I want to show you how to get the parametric form. And I want to show you how to get the Cartesian form one time. Parametric form is everything in terms of lambda, right? So watch this here. Remember I told you R is a random point, right? Or varying point on the line. So R, everybody ready? Kisha? R could be X, Y, or Z. Okay? So R is anything. R is any point on the line. Right? And well, we know what A is. And we know that here is 4 lambda. If I multiply it out, 4 lambda minus 3 lambda plus lambda. Right? So, Jacob, you see what is X? X is what? X is equal to 1 plus. Y is equal to what? Minus 3 lambda. And Z is equal to? Z is equal to 4 plus lambda. That's okay? This is called your parametric form, this here. Right? Parametric form is X, Y, and Z in terms of lambda. Everybody okay with that? Yeah? Anybody can guess how to get a Cartesian form? Cartesian form is in terms of what? X, Y, and Z, no lambda. So any ideas what I could do to get a Cartesian form? Substitute, you close. You close. You can make lambda the subject in each one and substitute, right? So you can make lambda the subject here, right? If you make lambda the subject here, you will get X minus 1 divided by 4. Right? Carry across the 1, you get minus divided by 4. Then, if you make lambda the subject here, you'll get Y plus 3 all over minus 3. Right? And then, if you make lambda the subject here, you'll get Z minus 4. Right, Marquis? So now everything equal to lambda. Therefore, I could just write it like this. X minus 1 on 4 is equal to Y plus 3 over minus 3 is equal to Z minus 4 over 1. That's it. Right? That's a parametric Cartesian. Any questions online? So here, I solve for X, Y, and Z. Here I solve for lambda.
I think, yeah, I can class. I got do the yeah.
Everybody okay with that? Right? So all I did is I made X the subject here. I kind of compare both sides, and here I made lambda the subject and compare them. Yeah? Do you think you could do the other way around? You think you could take the Cartesian and give me the factor?
Yes.
Yeah? So when you have here, make it equal to lambda, then make X, Y, and Z the subject, then write it like this and write it. Just do this. There you go again.
Hey, I know right now, it's trying to pay attention.
Oh, that was good. I'm very proud of it.
I guess not.
Copy that down. Right?
Yeah.
Oh, yes, yes.
Any questions online? Right, so as I said, the last thing that we have to do in this module is vector equation of a line and a plane, right? But I wouldn't rush the plane. We'll take the time on. We'll do that out next. No, we have no time. Go on, stop here. Hold your hand up. Ready?
You want to see it, that's it. $3? Really? Okay.
Try this here. Find the vector form.
Yes.
Oh yeah. Try that there.
What do you want us to do with that?
You can read it. I want you to start by reading it. What it says. Find the vector form, right? Yeah, find the so you're going in reverse, right? Yeah, I started here. Got it. I'm next. You okay?
Yeah, you can watch it now.
What else? What else? Three. Three. Four.
Yeah, I'm going to do nothing from there.
Okay, Ahmed? All right, guys.
I don't want to.
Right, next we're doing. I want to rush.
Yeah, I'll be better. But yeah, that one I can be under that.
Right, so remember you're starting right here, right? And make each one equal to lambda. Then make x the subject and then write it like that.
I don't know. So I think it's not the same.
I don't need to, I'm just trying to get you.
Right? And then make x, y, z subject. Right? Make them all equal to lambda.
Wait, what? Wait until.
Ah, really, well, that's not really.
Right? Anybody get that? Yeah. So you'd recognize that 432 is always the 432 is direction vector. You see that? Underneath here always gives the direction vector, and then the change the sign of these values will give you the point on the line. Yeah?
Yeah.
Okay? All right. Suppose I gave you two lines, right? I gave you two vector equation of a line. How you'll know if those two lines parallel? Suppose I gave you two lines. How will you know if those two lines are parallel? How you would know? Check the values well. Close that. Now. So if I gave you two lines, how will you know if those lines are parallel? Anybody? Yeah, how will you know? I gave you line one. Let's say line one is 4, 2 minus 1 plus lambda by 3, 1, 1. Right? And I gave you a line two. Line two is 8, 4 minus 2 mu 3, 1, 0. And I gave you a line three. Gamma. Right. Suppose I gave you those 3 lines. Cover? Sure. Look at those 3 lines there. The question is, which is parallel?
One and two.
1 and 2 parallel?
Yeah.
How? What you all think? One and 2 parallel, but why? Why you didn't say 2 and 3? Because there's a multiple of this, but any other point on the line?
Yeah.
So this doesn't give direction.
So
What
one
gives
and three.
direction?
1 and 3.
Right, this gives direction. So to determine the parallel, Keshav, you're checking the vectors out here. Okay? To determine the parallel, check the direction. Right? Check the direction vectors, not the points, right? The direction vectors. So we can see that L1 is parallel to L3, right? Because this is a multiple of this. You're seeing that? This is a multiple. This doesn't matter. You can have any point on the line. What's important is the vectors here. That's okay? L1 is a parallel to L3. Times 2 by 311 is equal to 622. That's okay? You're only watching this. That's okay? Last thing. Just tell me which one L4 parallel to. Tell me which one L4 parallel to. I'm giving you now. What?
That.
Figure them out. That's not good.
Smart guy. Smart guy. So 2 and 4.
Alright, which so you have to ideally put it in the vector form and then tell me which one is parallel to. Why?
Because that
Not wrong.
I'm not wrong. I'm not wrong. Right.
Right, so tell me which one L4 parallel to. Put it in the vector form and then you can figure it out.
So like,
Write it down in the meantime. Online, which one is L4 parallel to? Let's pick somebody online.
wow.
Bradley, which one is L4?
Nah,
L4 parallel to? Correct.
answer somebody else.
Oh, yeah, we'll go to L4. Right, determine what L1 parallel to.
Yeah, one eighty, one B, 0, 1 so yeah, back. So I find that why? No, exactly. Yeah.
Alright. So in vector form, you'll get R is equal to 2 minus 1, 3 plus let's change the letter. Let's change it to 5. It don't matter, right? 6, 4, 2. 6, 4, 2 is a multiple of L2. So it means that L4 is parallel to L2.
No, I guess.
All right. The next thing we have to do is learn about skewness and intersect. Right? That's my thing.
It's not. That's it.
All right, online. All right, online. That's it there, right? So we did vectors today, and we did the vector equation of a line today as well. All right, online. That's it there. You can log out. Thank you.
Oh, it's not really fair.
And they get it back later. You don't even need iron feet. Very on the inside. Is the traffic. I don't think something. It's why I'm seeing that, you go to.
Buenos días.
Yeah.